All right, welcome back to Applications of Calc 2. We're going to be talking about Newton's method today. So I think this is 12.6, Newton's method. So Newton's method is a way to calculate zeros of functions. And you might think, why do I even care about this now? Because I live in the 21st century, and there's so many things that will go ahead and give me the answer to this thing. And I'm like, you kind of have a point. However, if you ever have to write a program where you have to find the zero of a function, all of the things that do that for us are either free for personal use or cost money. So if you're going to do this and you're going to sell this to somebody else, you're going to have to pay the people who came up with this thought and do that. Or you might have to program it yourself. Okay. And the way that we're going to do this is we're going to say x to the n plus 1 is going to be equal to xn minus, and we have f of x divided by f prime of x. And this is what they call an iterative process. Okay, so it's a good thing to be able to do. And what we're going to do is we're going to guess, and I hate the fact that I have to use that word, but we're going to guess a first solution, and then we're going to plug it into the system. We're going to get an answer. We're going to say, we're going to plug that into the next value up. So whatever we get out of this piece, we're going to go ahead and push it into the next value, and then that's going to become our new xn. We're going to redo it again and again and again and again and again. Now, the nice thing about Newton's method is it's said to converge. That means it settles on a value fairly quickly. All right. So with polynomials, this is really nice because you need to do it about two times and you're going to get a good value. For other things, it doesn't have to do that very quickly. But the idea is you're going to be looking at a function and we're going to be dealing with a value. So we're going to get a value for this. Okay. And then what we're going to do is we're going to go get our value here. So we have we're going to get we're going to guess a point that's close to the zero. Here is our derivative for it. We're going to be able to do that. We go down to where the function is and we go ahead and we get the next value to come up until we start to get until we start to narrow in on the actual zero of what's going on here. This should get to be a better and better and better approximation of the actual zero every time we go through and do this. All right. So historically, because we have calculators now, we would calculate square roots with using this stuff. Okay. So the first thing I might want to do is like, let's figure out if we can estimate the square root of 5 by hand. All right. So we're going to say we're going to need x squared minus 5 equals 0. So the first thing I want to do to get a square root of 5, okay, is I want to make I want to make a function that has something I can take a derivative of in order to approximate what I should have, what should be able to get for 5 here. Okay. And we're going to do that. So the first two things I need is my f of x, which is equal to x squared minus 5, and my f prime of x. We're just going to take our derivative, and we end up with 2x. So as I'm going through this, we're going to pick a first value, and then we're going to take f of x divided by f prime of that x, and then figure out that arithmetic, plug it back into the original point here, and then kind of repeat the process until we get something that we think is close enough to the square root of 5. Okay, and again, I understand, like, I live in the 21st century. Like, I know, but this is part of the thing that we have to go and do. So that you know that there isn't a mystery as to why we get zeros or how we get zeros, that you know there is this iterative process in order to generate the solutions to these polynomials. This used to be something that people spent a lot of time trying to do. So we're lucky that we don't have to do quite this much of it. Okay. So here's what we have. And I might say, I need to pick something that's close to the square root of 5. And if you ask somebody like who doesn't know what the square root of 5 is, of what the square root of 5 is, one thing they might do is they might say, okay, well, it's 5 over 2. That's the square root of 5. We're going to say it's 2.5. Like, okay, not quite. That's not a bad guess, but I'll bet we can do better. Okay, and we're going to use the 2.5 as our guess for our first problem here and see if we can't refine our guess of 2.5 to be a little bit better as we go through this. All right. So what we're going to do is we're going to say that we need our x n plus 1. So our next value, we're going to say this is 2.5 minus f of 2.5. That's going to be 2.5 squared minus 5 divided by 2 times 2.5. All right. Now let's go ahead and just take a little bit of a break and say, okay, what is f of 2.5? Okay, and that's just going to be 2.5 squared minus 5. I got 6.25 minus 5, which gave me 1.25. Fantastic. And then on the bottom, we're going to say this is 2 times 2.5. That's just going to be 5. Okay, 2 times 2.5 is just 5. All right, so in order to get my next value here, what we're going to do is we're going to say this is 2.5 minus the value of the function, which in this case was 1.25, divided by 5. And we're just going to plug that in and see what happens with it. All right. Now, fortunately, I did that, and we ended up with, uh, where are we? We have 2.2, we have 2.5 minus, and I got 0.25 when I went through and did all of this arithmetic. 0.125 divided by 5. Yeah, I got 0.25, 225 or something like that. So I actually end up with a 2.25. All right. And that's my new guess for my square root of 5. A little bit different, a little bit closer. Okay. Now we're not done yet. We have to take this back. We have to put it back into the original equation. So we're going to say this is 2.25 minus, and now we're going to put this back into the original equation. We have 2.25 squared minus 5 divided by 2 times 2.225. Okay, so we're just kind of pushing it back in to see what happens with this. So here I ended up with, let's see, we got 2.25 squared minus 5 for my trouble on that one. Let's see, I think I got 0.0625. Okay. For my 2 times 2.25, we ended up with 4.5. Okay. So my next step on this whole idea here is we're going to do 2.25, okay, minus 0.0625 divided by 4.5. If I go through and do all of this arithmetic, I end up with 2.25 minus 0.013888889. Okay, I'm trying to be a little bit better about seeing what's going to happen here. So we can go ahead and check that out. Okay, when I plug that in, look at this, we get 2.25 minus um, 0.013 dot 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 dot, and we end up with 2.2361. Okay. Okay. Do we want to keep going? Sure, we do. So I'm going to take this number, plug it back into the equation, and we're just going to do this thing all over again. So I have 2.2361, and then we're going to say minus, and then here we have 2.2361 dot 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 squared minus 5 all divided by, and I have twice 2.2361. Okay, let's see what we end up with there. We have, if I go through and put this in, minus 5, I got 0.0001423, rather, and then divided by, and I got 4.4722 on the bottom. So I have 2.2311, 2.2311 minus, and I'm going to say 0.0001. 432 divided by 4.4722. When I plug that in, we actually end up with a total of 2.2361. All right. Is it 2.2361? Yeah. Um, Generally, when these last digits stop changing is when you're going to say, like, I think I'm good for what's going to be happening next year. Okay. I think I'm okay with stopping this process. Now, technically, this process never ends, but we usually say we want to get the value to within the 1/100th value. So when you see like, okay, we got 2.23, plug it back in. Oh, I got 2.23 again. It's not going to change this ever again. Okay, so whatever refinements we're going to get, and we can go on and on and on forever, but it's still going to be 2.23 and it's going to go on after that. Okay. So we're going to go ahead and check to see this because I want to know how close did we get because you haven't ever done this problem before. You don't know how much you're supposed to trust this. And I'm going to say it actually is pretty trustworthy. But let's go ahead and check out and see what the actual square root of 5 is so that when we actually go through and do this, we could say, oh, I think it's this. And how close are we? Okay, so as you're doing these problems on your exams, as you're doing these problems for your homework, you're supposed to go through this process, okay, to see what's going to be happening. If you go ahead and do your problem and then like, hey, the square root of 5, and you just did this, like I'm not asking you to type in the square root of 5 into your calculator and tell me what the answer is. I'm telling you, show me how the calculator goes through and does this. We got 2.23, and that's pretty much what we have on our as our availability here. So we have 2.2361. If I'm going to be looking at the calculator, I got 2.2361 to the four decimal places if I round it. Okay. So at that point, you can say, well, I got 2.23 every time I did this. Um, it's not going to change after that. So I think I am done figuring out the value, figuring out the value of the square root of 5 at that point. 2.23 is close enough for what we're going to be working with. Okay. So that's how you go through and do this. And again, when you're doing this on your exams, when you're doing this for your homework, you want to go through the process to actually do it. As you're doing it, you're going to see like the first number, the first two numbers are going to stay, are going to kind of stay put. Then you'll get the first third number. You keep doing iterations, you're going to get the first four numbers. If you wanted to keep going, you could, but for as many times as you're going to draw this thing around the circle, okay, think of it as a Krebs cycle. We're just going to do it over and over and over again. Um, you're going to get finer and finer and finer enhancements to this thing. It's just like, how close do you really want to be? Do we want to get it to the fourth decimal place? Do we want to get it to the 16th decimal place? 16 is going to take you a couple more times. The fourth decimal place is probably going to be a two iteration sort of a process here. So with that, I'm going to say thank you very much for watching the video. We will certainly do a couple of more of these, but thank you very much for watching, and I will see you in the next one. All right, take care. Stop.